How's everyone doing? Thought it was about time to bring you an overview video of my CNC mill. Let's get started. First of all, the enclosure is an all aluminum enclosure, 16 gauge aluminum. I've got Lexan doors, 1/4 inch Lexan doors. These handles conveniently came off some toolboxes and they work great for this particular use. Up here I have, the doors are just held, I don't know if you can see that, you can probably see it down here. Doors are just held in by neodymium magnets on the top and the bottom. Stainless hinges there. It's got a removable access panel in the back. This is just sort of a cross brace that goes along the length diagonally of the enclosure in the back. And this panel is removable, you know, so you can access the Y-axis motor and everything. One thing I'll point out is you'll see I ended up adding, these are just some secondary legs with adjustable feet, and they're not attached to the enclosure. They just help support the corners and raise up the corners because it wanted to sag a little bit in the corners. This is one sheet, it's bent here and it goes to about here. Same thing on the other side. This middle panel fills the gap. The top was bent 3 ways. So this side, back, and the other side is bent in the brake. You can see right here. And I used nut inserts or nut certs to screw the whole enclosure together. The front, in order to give me a door opening, is just angle aluminum. That is welded to get TIG welded together. See up in the corner there. And that gives me my door opening. And you can see that it's attached here with nut inserts again. Along here. This is angle aluminum in the bottom, filled with chips. You can see I've been using it quite significantly a lot. Okay, so the nut inserts are actually in the bottom. Also, another thing, while we're talking about the enclosure, is you can't, let's see here, this panel that goes in the middle here had to be 2-piece in order to get it in here and fill up the whole section. So that's removable. That's also gives me the ability, like if I want to do flood coolant, I can have a big drain pan basically in there, and even do, if I wanted to do a chip conveyor of some kind at some point, I could do that. Just stay on the outside before we get too involved on the machine. So let's go around. Well, as you can see, it's also bolted on the floor, bolted to the floor. Let's go around here and look at the side. So this is where all the electronics are. The coolant housing, obviously the monitor and the computer keyboard and everything comes off this side. The computer's just mounted down here. So let's just start with the electronics enclosure. So I built this cabinet, and it's just hinged in the back. And it's all steel construction. So basically we have an in and out filter, or in and out fan with filters. I have my on and off switch. This is for my electric fan on the spindle, which I'll talk about in a minute. That was temporary. That has now been sort of bypassed. This is, let me see here, this is my e-stop coming out. I use these connections, basically these pop open, they have screw terminals in them. You can see here, these are the same thing without the covers on them, more or less. This is where each motor comes in, motor connectors. This is the tool setter connector. And so I'll just go over what I've got in here real fast. What you see here is a Mesa 7i76E board. I chose to use Linux for my control software, and I'm glad I did. It's worked really well, and this is a really nice high quality board with a lot of expansion available, which is good. It's a good thing. My power comes in here, fuse holder here. Power comes in, gets split, neutrals, hots, grounds all get split over here. This is the power supply for the board, power supply for the fans, stepper drivers. They are Long's motor DM860A. I had a whole kit from them, but I end up not only using the drivers and the power supplies. These are 60 volt power supplies, and actually one of them went bad. No, this one went bad immediately. So I've actually got two motors on one of these power supplies. It's been fine. I actually have a new power supply. I just have never put it in because it's never caused me any issues. So, like I said, use these terminal splitters. That worked really well. This is one of those magnetic style on-off switches. As you can see, every single, these are all shielded. These are the motor connections to the drivers are all shielded. All the step and direction wires are all got ferrite beads on each end, on both ends. This is all shielded here. I haven't had absolutely no interferences at all. So that was my first, there's actually some old videos on my YouTube channel. My first CNC, I had occasional interference issues. So I was really conscious of that, and I tried hard to, cover all the bases as far as shielding went. So you can see that this is also shielded wire coming from the motors, of course. This is all shielded wire. And these are basically my end stops and my home switches and any other accessory that I have. These are computer fans. They work. They've been really good so far. I don't know how long they'll last, but I hope for a long time. So that's pretty much that, I think. Okay, well, that's how I turn the actual controller on. This here, so I just actually turned the VFD on via breaker. This is a 4 kilowatt VFD. One thing I did have to do was install this step down transformer, which basically is just a normal transformer but wired in a way that you actually cut off a certain amount of voltage, because my voltage coming in kept giving me an over voltage code on my VFD, causing me constant problems. So I put that in, and that fixed that issue. And the wiring ended up being, messier than I wanted it to be here, but that's kind of how it goes sometimes. You can see, like I said, the VFD, and I got all my connections coming out of the VFD. Right here is the main big heavy shielded cable going to the spindle. That was an eBay item. That stuff is very expensive, but I found a really reasonable deal on it through eBay. Used. I used the same cable to go to the main power, the breaker. Let's see here. So we'll go ahead and go to this. So what I ended up doing was actually moving my control up here in this box, and I'll tell you about that in a second. So that's what this is. Relay is not being used right now. I tried to get spindle control through the software, but it didn't work the first time, and then I just haven't really messed with it since. While we're right here, this is the coolant housings, just a water filter housing. That goes into like a splitter, so I can run my little air hose, my blowgun off of that. You get down here, you got your little regulator, and then I have a 12 volt solenoid that turns the coolant on and off. Okay, so let's come over here. So this box, it's actually a 3D printed box. I may mill it out of aluminum someday, but anyways, it's pretty nifty how I got it working finally. It took me a while to figure this out. You can see I'm missing, that's supposed to say fan and coolant there. But anyways, the way I wanted it set up was one switch to turn on the fan and the coolant. The fan meaning the spindle fan, and I'll tell you about that when we get inside the machine. So one switch to turn on fan and coolant, but then also if I wanted to at any point in time, I could pull out the coolant or pull out the fan, and everything can be controlled independently. I just didn't want to have to press two buttons all the time. Once you start doing this kind of thing, you realize that every little convenience is important, or just you know, it's annoying, and all that stuff adds up in time. So right here is just a potentiometer. It actually has a switch in it, which I'm not actually using. I found that it's actually not necessary. Moving this up here. Oh, one thing I will say, if you're gonna do this, I bought this ribbon cable just through Amazon, and the thing you'll note about it, when I first plugged this in, it didn't work, and I had to actually take one of the connectors off the ends and flip the cable over, because I can't remember which way it was, but instead of like a crossover cable, it was a straight through cable, or vice versa, one or the other. So you got to pay attention to that. These are my connectors. You can see I use a lot of these aviator connectors. They're cheap and they work pretty well. So you can see that took a lot of wiring and thought to get that all to function that way. And these light up. These all have you know, LED lights. Actually, I'll turn it on and I'll show you. So if I want to turn the machine on, I come over here. Here the stepper motors flip on. Turn the VFD on right here. And I would like to put in a, you know, like a 220 switch there instead of having to run the breaker, but it's really no big deal. So you'll see here, this is what it looks like, and it won't run until I hit start. So now it's started. But the cool thing is, after you turn it on and you press this green run button once, then it's fully, I just turn the RPM down, and it's got a, you know, a lowest RPM setting when it shuts off. So once I reach below like 130 hertz, it shuts down, and then I can just bring her right back up. You can see it's running. Of course, I've got a pretty slow ramp up. That's important to keep over voltage from happening, big spike. So yep, there's that, and this is the buttons. So that means right now the fan and coolant would be on. I don't have the air compressor turned on for the coolant, but it normally would be. So it's fan and coolant. I can pull out the coolant, I can pull out the fan, or I just leave it most of the time and it's just one button on and off. So that turned out really nice. Up here's my e-stop switch. Obviously, here is the setup. I got a Vivo monitor, keyboard stand, bolts to the back of the monitor. This is just a normal small TV mount that you would buy at Walmart or whatever. Like I said, I have Linux CNC on here, and I'm glad I made that choice. It's pretty versatile. It's a little complicated to get set up, but after I figured it out, it was worked out good. I'll go ahead and turn it on so we can move the machine around in a minute. Okay, so another thing I want to talk about is my motors. Let me just set you down for a minute. So these were my original motors from Long's Motor. It was a whole kit I got off of eBay. It was really reasonable. It was really cheap. It was like half price when I got it. And it had just a basic breakout board, these motors and the drivers that I'm using. Well, once I got the machine all together, I realized quickly that these motors are so slow. Super high inductance, and they're just, I think, what was my tops? I don't remember. It's like 60 inches per minute was max. It was skipping steps, and that wasn't going to work at all. So I actually found these motors off of eBay, and they are awesome. They're super fast. 150 inches per minute is what I've got it set to max, and it's not been a problem. I'm not cutting anything that fast, but I can rapid that fast, which for this size of machine is plenty fast. So I had to change those motors immediately, which was not really too big of a deal. and the other motors were hardwired in, but I decided that, you know, for future, in case I want to go to like clear path servos or something at some point, I can just, you know, I don't know if the connections, you know, be the same amount of connections or whatever, but anyways, it's not hardwired in. Okay, so as you can see, basic steel construction for the base, the legs. It's got, you know, it's got these support cross pieces here. These, basically, these bars bolt between these legs, these two end legs. There's one here, and you would have seen this in the other videos, but there's two under there, and that's actually where the linear rails bolt to. So the ends of these, after it was all welded together, the ends of these were all machined, all the pads were machined. You can see the main towers bolt here, two big 5/8 bolts. That was all machined. The pad on this bar and the bottom of this was machined. And then that is attached to a large, which I can't get to, but basically this is a big piece of tube with a big piece of plate welded to the tube, and the towers come in and bolt to these big pieces of steel here from the side, and then also from the front under the bellows here. You would see that. These here, my original intent is for these to be triangulating pieces. You know, I'm now bringing the support up to this height instead of just supported down here. It's much more structurally sound and rigid, and also was used to tram the machine, and that worked fantastic. It worked just as I hoped. I didn't even have to have any flats or anything to run these with a wrench or anything, because it was very close right out of the gate. I mean, you know, we're talking within a thousandths or two maybe of, you know, tram error, and that was very simple to just, it was a little tedious, but it was easy to just use these to either pull the towers in a little or push them up and out a little. So that worked great. As you can see from my lighting, I didn't mention this, these are just under cabinet lights, and they really work great, and they work even better putting them on the front here instead of having something overhead. There's not really any glare on the table comparatively to a light that would be overhead, so that worked out nicely. So as I mentioned, obviously there's linear rails under here and the ball screw. Same situation here. Let's see if I can get up in there. You can see the ball screw there, big steel plate. The linear, there's the trucks right there, and these are the rails up here. And you can see this piece right here. That's actually a 3D printed piece that keeps my bellow from falling down, because there's nothing, if before they just fell down and then got wadded up back here, so that didn't work. So I had to come up with a solution, and that 3D printed kind of tray just extends out just far enough to kind of support the middle of these bellows. Let me talk about the table real quick. The table, I came up with this idea. I've never seen anyone else do this, but it worked out really great. Basically, I just bought aluminum bar stock, and I made it out of aluminum so I could surface it with the machine. And basically, those are just threaded on the bottom, and this steel plate, bolts just come up through the steel plate and bolt the aluminum bars on. So obviously, all I had to do was just mill these two steps in this aluminum bar before I put them on, and then when you turn them over and you bolt them on, then you now have a T-slot table. So that turned out to be a really good idea and worked really well. Let's talk about the bellows. These here are just Bridgeport bellows. There are some different lengths and widths of these. I got them off of eBay. If you look at bellows, it's one of the most pain in the butt things of the whole machine build, to try to come up with effective, good bellows. And I see a lot of DIY machines where they just kind of said forget it, and they just kind of run them without them. I just couldn't do that. I had to find some solution, and so these were great for the table. And this one back here had to go up like this I'll move the machine around here. Just let me get into the software here. Well, I'll show you guys. So basically, let's see if I can get you in here where you can see it. This down here is my links to my controller. Okay, and the first thing you're going to do is just take it out of e-stop mode, and I'm going to bring this up just to jog it up to whatever, 80 something inches per minute, jog it around. And while we're here, let's just go over the screens real quick. These are red because it's not homed yet, and let's see, let's just go ahead and home it. So you can see here, one thing I was talking about, I want to finish what I was talking about with the bellows here real quick. You can see this bellow just kind of swings forward and then just swings back. That had to be up like that. It couldn't work like this one because it interfered with the motor back there. So that's what I decided to do, and it's ended up working out better than I even thought. You can see here, let me go up a little. I like to jog it close to home so it doesn't have to seek in the super slow speed. I'm going to go ahead and home it. So it's going to home the Z-axis first, hit the switch, come off the switch 200 thousandths on all axes. Same thing here. And we'll talk about the end stops, the home switches in a minute. I could have cleaned the machine, but I wanted you guys to see how much I've actually been using it. Okay, so let's just go over the screen real quick. Now you can see these letters are green up here, or these numbers. That is your absolute coordinates. Oh, I'm sorry, that's not accurate. This is your absolute coordinates. These are your G54 coordinates. So basically, if I wanted to find a part, say I just found the corner of this part, this is your where you zero out your offset. So I would just hit X, Y. Now that makes those two a 0. Same thing with Z. Then go back. And this is your different jog increments, continuous, and then 0.1, so on and so forth. So that was your homing. One button there. Go back. That is your offset page. Shows your different offsets there. Let's see here. And this is your tool page. That just shows your tools. And I haven't really actually. It's not important for me to fill this out because I don't have preset tool lengths. Over here, you can go to MDI, which is where you can manually enter in your code. This is where you load your program. So let's see, let's load something here. And this is my when I was working on this fixture plate here. Let's see here. Let's go op 1 spot drill. Okay, you can see there, that was 664 holes on this fixture plate. But that gives you a graphical representation of your code. This is your code as it filters through. Play, stop the program, pause. One thing I do like about Linux CNC, and I know they're not all like this, when you pause it, it instantly pauses. And when you press it again, it instantly starts working again. There's no kind of lag there, which is pretty important. Obviously settings. Now I will mention that this screen here, this screen set is not the normal one. It's called GMO Cappy. I don't know how you say it. GMO CAPPY, I think. It's just a different screen basically, and it's optimized for a touch screen, which I want to get at some point. So let's go back into the machine here. I want to talk about these bellows next. Now, I mentioned this before in some of my other videos, but I actually built these bellows from scratch. I got some PVC coated vinyl, and if you want to know more information about that, I can give you a link and I basically glued it with upholstery glue, high quality real upholstery glue out of a spray gun. Sprayed it to craft paper. Used the craft paper to draw out the layout of the folds. And I got the layout of the folds by a piece of software, a simple piece of software that is online. I can get the link to someone if you're interested. That gave me the dimensions of the layout, and I basically just drew that onto the craft paper, and then you have to hand fold the bellows. Clamped them after they were folded, clamped them in place for several hours, for a few days, and they worked pretty great. They were a ton of work, but that was really my only option. Sheet metal, just sheet metal capturing cover here and on the bottom, just aluminum end plates basically that just kind of cap out the end and give you somewhere to attach the bellow. So everywhere, these were kind of a pain too. I had to cut these little pieces of strap for here and all of the edges to hold the ends down, and I had to punch through the vinyl, you know, for the holes. So that was quite the job. I've got one here, it's crunched up obviously. Let's you can see there how that works. And they work great. They keep all the chips out. You can see I also got side covers here so that absolutely nothing can get in. You can see I've got a close clearance here for this side cover that attaches to my main plate. That keeps everything totally clean. This is the most exposed set of linear rails, but so far so good. Nothing getting on the actual rails or ball screw. Next, well, let's talk about the spindle. So the spindle, I immediately had to replace the bearings on the spindle. Chinese spindle. I knew this was a possibility. It happened faster than I even imagined, but I took it apart myself, found a video online that kind of gave me some direction on that, and I bought some really high quality bearings. NSK super precision angular contact bearings. These things are very, very expensive, but I was able to get them for a very reasonable deal on eBay. This is the box for the top bearings. Basically these have two big bearings, angular contact meaning, so there's a pair, there's always a pair of them. And this is another pair of bearings for the top. Same scenario. I had to buy this super expensive lube for the bearings. I think just this little tube was 35 or 40 bucks, and that was cheap comparatively. Let's see here. So another thing I want to talk about is when I ruined the bearings, I thought maybe that it wasn't cooling properly because I was running it towards the bottom of the, you know, the hertz range, I guess you could call it. And so I was worried that it wasn't cooling fast enough because it had a fan directly attached to, you know, the top side of the, you know, the main part of the motor, the shaft, the rotor. And, you know, the fan only pushes as much air as it's turning. You know, if it's the faster it's turning, the more air it's pushing. In order to ease my mind on that, I bought this really high quality, I'm trying to think, I forget the name brand of it. It's a very, what is it, Pabst or something like that? EVT Pabst or something strange like that. It's a really high quality fan, pushes a ton of air here. I'll turn it on, you can just hear it. So it's winding up here. Feel all that air. I can feel a ton of air pushing through here, so it pushes through this whole body and inside of it. And just grab a piece of, you can see how much air it's pushing. That actually helps blow chips out too and everything. Okay, so that's what I did for that, and basically I 3D printed this, which turned out great. It's like a big funnel on the inside that attaches to the spindle, you know, in its normal configuration. and then just extends this bolt pattern out here, and this has those pressed in heat. You heat the threaded insert and put them in plastic, and those were great too, by the way. Next thing I want to talk about probably is my switches. I just went with basic switches, which work fine. They're not super accurate, obviously. Maybe I will end up putting some more accurate ones for the home position. But basically it's all 3D printed mounts. And there's just a bar here, it hangs down. This right here is fully adjustable. And man, they work fantastic. Those mounts worked out great. This is this axis. I actually don't use this one, but same scenario, and this is fully adjustable, as you can see, and up and down, and then this bolt is just adjustable in length. You know, I want to maybe someday, if I take the time, build this stuff out of aluminum, but it works fine and great the way it is, so I'm not sure that I will. What's next? Okay, so let's talk about the coolant system. As you've seen, I've got a water filter housing with coolant in it. I've got a regulator, and basically the way that works is it works just like a oh shoot, can't think of the name of the normal coolant, low volume coolant system. Air comes in to the regulator comes out to my solenoid is split, and that goes to, one line goes directly to the manifold that I'll show you, and then the other line comes through the filter, pulls the coolant up, and goes to the other side of the manifold. This is a backflow valve to keep it from flowing back on me. So both of those lines come into this manifold, which I built. These are adjustable fittings. I don't like these fittings. They don't really work very well at all, but more or less just have to adjust the pressure out here to adjust my flow, because these just don't, I don't know why, but they just seem to make hardly any difference at all. They're just cheap. All push connect fittings. The air comes in, coolant comes in, and there's a very tiny bore in here. And this is another push connect line, very small. I don't remember the size, top of my head. That comes in, and I actually used a tip for a MIG welder and turned down the other end to make a barb out of it and push this onto the barb. And that works fantastic. It was just a perfect fit on the inside of this 1/4 inch lock line. I put a little glue in there, and that's it, and that's worked fantastic. One thing I will say about getting the hose in this, because normally there's not a line going down there to suck fluid up. It's just filtered through. So the way I did that was, it worked out pretty slick. So these fittings, if you ever look at them, there's just like a gripper in there that seals the hose, and then the hose just kind of hits a metal stop, you know, a machined in stop and fitting. And what I did was just drill out that machined in stop so this tube could just keep going that way through the fitting. It still seals, everything works like normal, it just nothing to stop it and keep it from just continuing through. So basically the way it works is you put that in, continue it through, put a union on it, and then just put another length of hose on, and that works fantastic. Well, I'm thinking we're about to get it mostly covered. You can see cable chain here. That's nice cable chain. I just have a drop PVC electrical conduit drop here. Got my little tools over here hanging. This tool setter has been great. I didn't use it at first, and it got annoying pretty quick. So I dug around on the Linux CNC forum and eventually found the code to make this thing work. And ever since I got it working, it just works flawlessly. It's super accurate. I just don't have to think about that anymore, which is just such a relief. It's one of those little annoying things that you have to reset and zero every single tool you put in. It's just not that accurate and a huge pain in the rear. So just to show you kind of how it works, it's got a couple pieces of code in it, and I won't explain that. But basically, before I run the first job, I run an M600, which is remapped to, you know, this block of code basically, and that just tells it the first tool you zero like normal, and normally I zero it with paper, and that usually doesn't matter on the first tool. It doesn't have to be super accurate because it's cutting away, you know, it's facing the material almost always anyways, so it's kind of creating its own starting point. But anyway, so as you zero that tool, that M600 command tells you that this is now the first tool and it needs to be the reference tool. So it goes over, takes a reference measurement but doesn't change any offsets, takes a reference measurement, stores it, does your work. As soon as you change the tool, it now knows, until you run the M600 command again, it now knows that every tool needs to be set to the exact same height as the first reference tool. So it goes over, finds the height, changes the offset to match, and it just works flawlessly. It works great. Well, I think that is about it. I don't think I can think of anything. I've been working on this fixture plate, 664 holes. I think I just mentioned that. This is going to be necessary. Some of the stuff I've been doing, I used right here, small fixture plate I just bought off of eBay, and because I'm flipping everything, this is the vise I'm using. I'm flipping everything, so this fixture plate works great for that. This little vise is a basically grinding vise, 3-inch opening. It works great. I think it's very accurate. I've never actually measured it, but it seems very accurate, and it works good for what it is. When I'm thinking about programming things, I don't really program them for the vise. The vise is just a convenience thing. It's really not as convenient as a big vise, but it works great for what it is. You can see here I did some engravings, and that's just a label project that I'm working on that I hope to bring you guys along with. That just means op 0 pin, 1 pin. And basically what this is 2 pins for the stop bar for my first op. These are Mighty Bite, these clamps here. So basically my piece of stock goes against a stop that's pinned here and bolted. Mighty Bites are here that holds the stock while I pre-drill the holes, and there's 3 of those, 2, 3. This is just for one particular project. This is universal, but I labeled it for this particular project. Then you can do 4 of, after they're drilled, you can go and bolt it. You know, you'll bolt it 1 here, here, wherever else. The labeling is just some labeling that just kind of helps me know what I'm doing. Got counter bores here. I only got 3 bolts in it. I got to buy some more T-nuts. Anyways, it's working good. I want to show you guys. I'll give you a sneak peek what a couple things I've made. Let's see here. One of them I don't have finished. I finished one for a customer, a friend. This is a second one. This is actually a 3rd brake light. You can see some very complex machining. My ball-end mill for this particular one got pretty dull on me, so that's why that's kind of like that. But little tumbling or blasting or whatever would just take all that stuff away. It's it's very nice finish overall. This is like a 2nd op here, then there'll be a 3rd op here. This is the 3D printed prototype of the piece. Like I said, I did one. You can see how this doesn't set flat because I did the first one for this individual, and it kind of sets in a reverse curve on a car. So that was my actual first main project. This is what I've been working on. This will be my first product that I want to bring to market. And these are just shifter handles or shifter levers for Tremec 5 speeds and 6 speeds. See, they're quite beautiful if I say so myself. Here's the first one out of 1/2 inch that ended up being too thin. This one here, these inserts, I'm trying to figure all that out or do it the way I want to do it. These are actually machined out of brass. They're actually chemically blackened like you would glue a gun, and they look super nice. Shine them up on a Scotch-Brite wheel first, and they kind of give you this sort of, probably can't see it and they're dirty, sort of black chrome look. Looks good. And so they'll be they'll be fully inserted everywhere. It'll be an option. You can see my little logo painted in there. Whoops. See here, I experimented with actually sandblasting the pockets. Like I said, this is a little dirty from just handling it, but overall, that's not the right one. Overall, they're going to be very, very nice. I have a lot of experience in the automotive market, so I mean, not really the market, but basically I grew up in a shop and that's what I do now. My main job is automotive restoration, fabrication, machining, all that stuff. Not really any CNC machining there, but regular machining, fabrication, welding. So I decided the first products that I wanted to bring to market were automotive products that made the most sense. So this will be eventually an air cleaner nut. Kind of a serious air cleaner nut, but I think it'll be cool. I wanted a small item that was, you know, fairly quick to produce, fairly reasonable, maybe like a $20 item or something. This is the first one. The way I had it held was not good. That didn't turn out as good. This one I held correctly and used YG polished end mill to get that sidewall finish. Looks fantastic. There's my little logo again. Scotch-Brite wheel, fiber wheel finish on the top. So that's just, these are my main focus right now. I've got a couple blanks prepared. See that finish? Finish is great. So that's that fixture plate. That's what those were marked. Those engravings were for. So I'll be able to do 3 bars, pre-drill bars at a time, which I'll probably just pre-drill a bunch of them, and then I can do 4 handles at a time on that fixture plate, and that saves a lot of time from doing all those tool changes, because the tool changes is what takes time. There's not really any complex, super time consuming stuff on this. I've got to drill the ends, which I'm going to make a jig on the CNC and use the jig with the big mill and come in with the horizontal spindle and drill those. This is another project that I'm working on that I hope to show you guys. It's a tumbler. I don't want to get too involved in it, but there's the tank for it and the base for it and a lot of the components sitting there. So anyways, this is a 3D printed version of another one. Just a simple ball mill lines. Can't really tell too much by this 3D printed version, but sort of what I call a valve cover style, like an old Edelbrock valve cover look. That'll be even simpler to machine. That'll probably be a little bit cheaper than the others. So that's that. It kind of gives you an idea what I've been doing, and I just thought you guys might enjoy that overview. I've got a lot of footage of stuff I've taken, obviously not posted anything. I still just haven't found time to do much editing or anything. Really haven't even got into that very much, don't really know too much about it yet, but I want to post some videos and you know, share my experiences and share my products, and you know, just see what you guys think. So anyways, that is the CNC fixed gantry mill. Well, I hope you guys enjoyed that overview of the CNC mill. A couple things I want to mention is the cost was roughly around $3,000. And that's finding every deal that I could and doing every single thing myself. It took me about a year to build. $3,000 in the scheme of things is nothing for a CNC mill, and I think for the money, I don't think that you could possibly do anything that would give you the quality and performance that I've ended up with for any less money. I think that the quality to cost is really good, and I'm really happy that I did it, and I've learned a lot, and it's been a good experience overall. Yeah, so I'm super happy with it. There are a few upgrades that I want to make to it in the future, and the main thing would be an automatic tool changer spindle, you know, stuff like a touchscreen monitor, jog pendant, maybe servos at some point. Overall, it's doing great. We've got a lot of cool projects ahead, and I hope to bring you guys along on it. Stay tuned, subscribe, see you on the next one.